Good afternoon, everyone, and thank you again for joining us. So we're going to be covering a lot of ground today with our speakers, so questions will likely pop up as we go along. Our speakers will be happy to answer any questions you may have during our Q&A period at the end of the session. Throughout the presentation, feel free to type any questions you may have into the GoToWebinar question panel, and we'll do our best to get to them all at the end. Our webinar today will be recorded, and you will receive a recording from us tomorrow. If any questions arise after we wrap up here today, you can simply reply to that email and we'll put you in touch with the appropriate team members to get those questions answered. So without further ado, I will pass things over to Rob to get us started.
Thank you, Sarah. Thank you everyone for joining us. It's a pleasure to be with you again. Joining us on our webinar today on how to handle or how to enable shop floor and quality assurance teams with modern metrology tools. My name is Rob Johnston. And I'm joined today, just gonna click here, joined today by two guest speakers, Dennis Dewson, president from Alps Welding in Toronto, Ontario, Canada, and Mahdi Sharif, developer and co-founder of Glove Systems. And today we're gonna be talking about modern metrology tools for shop floor personnel in a specific metrology and manufacturing segment. So I'm going to be welcome to those two speakers, and we'll be handing it off to them in a few moments. Just going to introduce a couple of different parties and the scope of these solutions, and then we'll jump right into it. So first off, I'd just like to introduce ourselves. We're CAD MicroSolutions. We're a Canadian-based partner for a variety of different metrology and measurement solutions, including GOM, including ZNF area scanners, and of course, Glove Systems and their cloud-based software solutions. I'm also very happy to be joined by Point 3D and the United States audience members that may be joining us today. We know that Point 3D is a proud partner of Glove Systems as well. So thank you for joining us. And if there's any questions that come up, please feel free to ask them as we go through the presentation. CAD Micro is what we call an innovation enabler. We are in a variety of different businesses, including selling, supporting design software, advanced manufacturing, advanced simulations, 3D scanning and metrology, and of course, this new venture of AR/VR. And today's presentation is obviously all surrounding 3D scanning metrology and what some of these tools offer to people in the marketplace. Metrology comes in a variety of different forms, whether you're a component level inspection, automated inspection, CAD-based SolidWorks tools, and of course the focus today is going to be on large-scale metrology solutions, area scanners, and the relevant software. And to position this kind of work and where we are in the marketplace, I just put together a small little presentation here that will kind of illustrate where these tools are really successful. And on the bottom of the graph here, you'll see I put a part size. That is, as we're inspecting parts that just get bigger and bigger and bigger and bigger, your obviously tools and requirements for those parts radically change. And where I put this red line on the graph is, all of a sudden when parts become too big where you can't bring them into a metrology lab or a measurement specific area, and you've got to take the equipment into the field or to the device or to the thing on the shop floor, it radically changes how metrology is done. And Glove is a great tool for that, and we're going to show you that in a few minutes. As part size increases, so does our inspection time, but our tolerances typically get bigger as well. And as if we look at different typical historical metrology tools, you've got vision systems on the very low end in terms of small part sizes, CMMs, all the way up through a variety of different devices. Microscope measurements all the way up to area scanners on pressure vessels or large fabricated containers. And very simply, the smaller the parts, the traditional higher volume production, medium volume production, and then low volume. So the bigger the parts, just a very different metrology mindset, and it's why different tools are required. We're going to be focusing today in this kind of region of where we're parts that would be a little bit too big for CMMs, where we'd use some kind of scanning device, which would be a handheld scanner, a traditional inspection arm, or an optical tracker or terrestrial area scanner. So that's kind of just our focus in terms of when we're saying shop floor, because I know there's shop floor CMMs and other shop floor devices. We're going to be focusing on a little bit larger scale today in the presentation. And then, three of the big challenges in that environment are, what are the QC solutions available for those large parts? How are people doing their documentation control? And then how are we feeding the results of that back to design in terms of fixing the parts? So I'm really happy to be joined today by Dennis. Dennis is the president of Alps Welding. And at this point, I'm going to hand it over to Dennis and Madi to go through their presentation, and look forward to what you guys have prepared.
Great, thanks, Rob. Just unmuting myself here. Yeah, thanks for inviting me to participate in this, and hopefully our experience is valuable to the audience here. As Rob mentioned, I'm president of Alps Welding Limited. We are a pressure vessel fabricator for the most part. About 2/3 of what we do are registered pressure vessels, but we do other non-pressure fabrication as well. We're located just outside Toronto. We have about 70 employees, and we're servicing mostly a lot of different industries, but really what we're building are kind of highly engineered, custom fabricated units. So it's vessels, water filtration equipment, heat exchangers, stacks, for the most part large in size. Vessels in the 8 to 10 foot diameter range would be kind of medium. That's kind of our bread and butter. We do a lot of those kinds of vessels. So larger fabrication, and everything we do is designed by our customers, and we're building, if we build a quantity of 5 items, that's a high volume order for us. So, high variability, low volume custom fabrication. So that's our business. We're serving specialty chemical, oil and gas, various parts of the energy sector, food manufacturing, a little bit of pharmaceutical, and steel making. Really, a lot of the primary industrial industries. And we work in a variety of different materials. So a lot of carbon steel. We have a segregated alloy shop, so we're doing stainless steel, titanium, and other exotic alloys as well. So really a lot of diversification and a lot of different kinds of customers, a lot of different kinds of products. So that's our business, and I'll let Madi describe a little bit of our relationship with Glove, but we've been working together for a couple of years now on using some of their solutions.
Yes. Thank you, Dennis, for agreeing to participate in this. I think your experience is far more valuable to hear than us talking about our product. But Rob, if you could put up the last slide. I think we're seeing your final screen, but if you could put up the last slide, that'd be pretty good context for this conversation. We worked on various things with Alps, but I think after 2 years of working and validating our product with it, we kind of landed on 3 buckets of value to Alps. And you can think of Alps as fabricators, and other side of being fabricators to the projects. And those 3 buckets are the things that we want to talk about today. The rest of this session will be around the examples of each one of these value propositions to Alps, and some demo of the application. So the 3 things that we kind of landed on that we provided value to Alps was around quality control. Most fabrication shops use tape measures and bubble levels and traditional tools. So when we approached Dennis, he was intrigued, and we could talk about some of the accomplishments we had in the world of quality control. Of how could you have an application that's very easy to use, fast, it's accurate, and then bring it to the hand of the fabricator so that they could use it for their quality control. The other bucket of activities that was valuable to Dennis, and we want to talk about it today, is around documentation. So as built today are written PDF documents with measurements verified with a tape measure. So that's not really as built. What we wanted to do was make that 3D stored in the cloud, make it shareable, and allow the fabricator and the project manager to collaborate on that quality document. And then the last thing, which is kind of we step into, was around, well, what if you have an existing assembly like a pressure vessel in an existing environment, and you're both responsible for designing the replacement part and fabricating it. So we ended up developing tools and methods to allow the fabrication team to scan the site location, get the required connection points, feed that to their design teams, and then make sure what they're fabricating would actually be able to install properly on site. So Dennis, I think these are the three things that, you know, it would be valuable to hear your perspective on, both on quality control, what's been your experience in terms of this modern way of doing quality control, examples we've done in the past, the value of documentation to you as a fabricator, and the value of easily getting accurate set information and feeding that back to your design team.
Yeah, so to address the first one is the quality control aspect. I think this is really kind of the primary intent of our of our relationship with Glove, and why we started to pursue looking at their tool and their system. We do a lot of quality control. We do a lot of inspection, and we, out of our 70 employees, 5 of those people are full-time quality control, quality assurance people. So it's a big investment. And as we're building any project, but as we're building a vessel, there are multiple hold points or witness points in the fabrication, along the fabrication steps, where we have to stop and do quality control verification. And that might be, looking at the internals of a vessel. It might be, verifying a fit up before we start to weld. So there's a lot of recording of dimensions and verifying of dimensions compared to the model or the drawings or the specifications. So it's a big investment, takes a lot of time, requires us to start and stop a lot, and it's manual. So as Mahdi mentioned, those dimensions or those inspections are really performed by tape measure. Tape measure in a smart level or a bubble level, they're not particularly advanced tools. It's a very human kind of inspection, and there's often there's human error that can creep in for sure. There's discrepancies in interpretation of some of those measurements sometimes between us and a customer inspector or some third-party inspector. So it can be a messy process. And then those are all kind of all in-process inspections. But then at the very end, we do a full final inspection of a project, and we verify that all the critical dimensions are being met to within tolerance. Again, it's done by measuring tape, and it's done by recording everything on a drawing and verifying everything. So we've started using Glove systems. We've done some in process, but definitely we've been using it mostly in sort of the final verification, where we've got a completed vessel and we can do a full scan of that vessel and compare it to the 3D model that comes out of SolidWorks and see if there are any discrepancies, from what we built to what was in the model. And it's what I like about it is it's objective. There's not a ton of room for interpretation. I mean, the laser sees what the laser sees, it's not somebody holding a tape measure and making sure they're reading it right. So that's really useful. The other benefit we've seen is that using a laser scan of a full assembly, you can take dimensions that are difficult to take by hand. So you might have dimensions that are in different planes. You might have to take dimensions from different points on a vessel that are very far apart, that are impractical to do using a tape measure. Sometimes there's a dimension that's kind of off into space, like the center of a big nozzle, for example, that is hard to measure. But you can take more of those dimensions and measurements using a laser scan. So that's also been very useful. One thing that's really been interesting is having the objective laser scan allows us to avoid, if you want to call it like a group think mentality, or somebody makes a mistake and then everybody along the line takes that mistake and builds on it. So we've had examples where a fitter lays out a vessel, lays out a hole in a certain spot, and he's taking a dimension from a certain place, and he says, yeah, that's good. Then the inspector comes over and he verifies it, and he takes that dimension from the exact same place that the fitter did, and they both agree, yeah, this is all good. But if that first person is using the wrong reference point and measuring from the wrong place, everybody all along the way can be measuring it wrong. And having that final scan with an objective system like a laser will point out something that maybe all along the way we didn't notice. So we had one example last year where we built something, and there was like a hinged cover on the end. We put the hinges on the wrong side of the vessel, so essentially the whole thing ends up being backwards. And because everybody's looking at it the same way, everybody's saying, yeah, this is right, this is right, this is right. And it was only at the end when we looked at it and said, no, something's wrong here. What's wrong? We had to go back and say, hey, we made a wrong decision early on, and then everybody kind of carried on with it. So having something objective like a laser helps to catch things like that. So that was kind of an unintended benefit that we have seen. So that's been our experience, and it's added value in a number of ways, and given us some capabilities that we didn't have. So now we're kind of at the point where we're trying to use that more for in-process inspection. So we're not just catching things at the end, but we're catching things in process. So in terms of quality control, that's some of the areas where it's helped us. And I think, Maddie, you wanted to do a little demo or show
Yep.
something to demonstrate that?
Yes. So
Yeah.
I think that for the rest of this presentation, I have a few examples I want to kind of show to the audience of different workflow of the application, the easy to use aspect of it, the cloud portion. So for the rest of this presentation, I'll take control of the screen. I'll go through the examples, and then we kind of can loop back and then go through the questions and go from there. So I'm just gonna have to figure out the right screen to share. Screen, there we go. I'm just gonna put this over here. Gonna put this over here. And this, can you confirm that you can see my screen with the glove application on?
Yes, yeah, I can see it.
Okay, great. So what you're looking at is the overall application. Our application, the glove fit application, installs on a Windows computer. You would have to sign up with us to be able to log in. But when you do log in, this is the interface that you're looking at. And I have 4 examples to kind of cover the 3 buckets of activities that we talked about and show you the workflow. Of course, the things we've done in the past and the things we focus is not limited to these 4 types of assemblies. This is just a quick way of introducing the application to the audience. So on the left-hand side, you have the list of assemblies. So for this particular example, I have 4 assemblies that I want to demonstrate. So we can think of a project with many, many more assemblies. For each assembly, you have 6 tabs that we're going to kind of walk through today. So the first page you have is the overview page, which is the idea of having the design drawing over here, along with some attributes around, when was the design created, who created it, because our licenses, the way it works is you're going to have enough in your shop to have everybody signed up, because you're going to have your designer load in the design, you're going to have your QC to gather the data, you're going to have the QC manager looking at the quality, cultural information. You want shop managers to also have an oversight role into the quality workflow. So the next page, once you have your design information, here is the scan and match tab. And what it is essentially the 3D model next to the 3D scan. So I'm just going to wait for this to load here for a second. So on the left-hand side, you can see what we call the as designed. This is, essentially what you need to build. And on the right-hand side, you have what we call the as built, what you currently have. And there, as Rob mentioned at the beginning of the session, there are different ways to get to this as built point cloud. There's long range scanning, there's short range scanning, and in the world of scanners, there are different models and types, and depending on your budget and quality, we could help you to find the best option for your application. But at the end of the day, what you do need is to have an accurate representation of your build. Once you have that, then the problem becomes, well, how do you map what you have to what you should have? And the way we do it is we ask users to pick 3 corresponding points between the model and the scan. Those 3 points do not need to be exactly the same spot. As long as they're in the approximate neighborhood, then our mathematic engine can take care of aligning the 2 data sets. So this is what's happening on the scan and match page. Once you have your points picked, once you have your as-built collected, then you move on to the analysis screen. On the analysis screen is where you can do all your quality control assessments. So for the purposes of this demo, you can see that I now have my as-built mapped to my as-design. So you could see that, for example, I could easily detect that this component has not been installed. I could turn off my scan, I could turn off my model. But what you're looking at right now is the model superimposed on the scan. Now, you may ask, well, why is the scan colored? Well, what you're looking at is what we call the heat map. The heat map is a very fast way to get to a yes and no quality control visualization. So what it means over here is that any points that have more than 6 millimeters of deviation are now colored in red. So for example, the points at the staircase, I could see that they're all red. And if I wanted to look at it from side view, I could very quickly see that my points are standing out. Now, in this particular case, it didn't really matter to the fabricator because the stairs came as parts. But however, if you wanted to know what is the deviation at this staircase, what you could do, you could simply pick a point and then look at the deviation for that point. For example, for this point, the deviation is around 17 millimeters. Now, in addition to looking at deviations, you've got other tools as well. You could look at a distance between a corner to another corner. So in this example, this distance is around 3.4 meters. And then once you do some quality control assessment, and I want to note that to get from a scan to this analysis, it takes around 5 minutes. So in 5 minutes, very quickly, you could do some overall quality control assessment. In addition to the point cloud analysis, we have the concept of photos. So if there are things that you want to capture that are captured in a photo, you could do that. Each photo you can comment and share. In addition to photos, you could store reports. So if they're third-party hydro testing, quality control, weld reports, all of that could be stored as reports, can be commented. Now, if you remember, we talked about the application being fully cloud-based. So everything that you do in the application can be shared externally to your client, or if you're a project manager, you could ask your fabricators to share it with you. Or if you're a fabricator and you want to share it internally, you could do that. When you do share an assembly, the recipient will receive a link in their email. Once they open it, they can log in to this portal view. In the portal, they could look at the drawing, they could look at the model, they could look at the analysis, they can look at the photos, and they can also look at the reports associated with the assembly. And in fact, one of the things we're going to do after this webinar is to share a link related to this very specific assembly so that you could look at it in your browsers as well. Looking at the shared content does not require you to have the application installed, and that's a huge value that allows unlocking of quality control data and creating this relationship with your owners or clients or fabricators. So this is a simple example. I want to show a few other examples that we actually found an issue on site with the help of the quality control personnel. So the next example that I'm about to show is an actual pressure vessel. And in this example, the quality control personnel on the shop floor use our application, use the scanner to collect the data, do the analysis, detect an issue, and then fix it right there and then. And this was an issue that was missed. And they were able to detect it just because of the value of 3D data and how easy it is to visualize. So we're going to look at that together right now. So again, on the left-hand side, we have the 3D model. On the right-hand side, we've got the 3D scan. Then I'm going to move on to the analysis screen. It'll depending on the size of the assembly, the analysis can take up to 30 seconds all the way up to 6, 7, 8 minutes. If you're scanning and you're now analyzing something very big, it may take a while just because of the size of the data. Okay, so now I have my pressure vessel mapped to my scan point cloud. So immediately when we looked at this, we were concerned about this top flange here. So you could see it's all red as well. So if I get it to a section view, I could see that my flange is standing out when compared to the model. I could even turn off the model. So you could see. So this is the as built, and this is the as design overlaid on the as built. So we were able to detect this issue. In addition to that, we're able to detect the issue with the flange inside. So if I bring this over here for you to see, you will realize that this flange is slightly off. So when we detected the two issues, I also like to comment on the fact that there's a lot more red on the outside of the pressure vessel. That may seem like an issue, but it's really not. In the world of pressure vessels, Dennis can talk about this too. No pressure vessel is ever a perfect cylinder, so the outer roundness of the body is not an issue, and that is why when we onboard clients, we always say green means good, red means potentially bad. Not every red point is necessarily bad. You just have to understand your quality control requirements. But in this case, the worker was able to quickly detect the issue. Once he did that, he then used his manual tools to double check and verify the issues. The interesting part was he was able to verify that the issue existed for both flanges. One was about 1 degree off and the other one was about 0.1 degree off. And having this visualization, they were able to share the issue with the client and then have them agree to the small issue with the inner flange and then rework the upper flange. And that's the value of being able to communicate with your clients. Again, everything that we do is cloud-based. So if you come over here, you can look at the analysis screen for this assembly. You could look at the photos. And then if the reports exist, you could look at the reports as well. This can be shared internally and externally. The last case around quality control that I want to share is something completely different. This is a large modular assembly that we inspected. And just to give you a scale of how big this is, so this module is around 15 meters long, and you can see the scale of the module next to me standing and trying to scan it. So after overlaying the scan onto the model, where I'm going to show in a second, so on the left-hand side, you can see my model, and then the right-hand side, I'm loading the scanned assembly. So this is the model, and the right-hand side is your scanned point cloud. In this case, I have deliberately not generated the heat map. And even before generating the heat map, we were able to quickly detect a major issue with one of the pipings in this assembly. So if I bring this into the view here, you could see that this pipe over here, it's completely out of alignment. And we were able to detect this even before generating a heat map analysis. So this pipe here is what exists on the module. And if I turn on the model here, you could see that where it needs to be, it's completely off. And we were able to do this detection in less than an hour. So that's the power of 3D data and how quickly it can spot some major issues with your assemblies, specifically when they get larger and more complicated. For the final part of this demonstration, I want to talk about the last bucket of activities, which was around helping design teams and helping with the case where an assembly exists on site and you want to design a replacement part. So this was a case where in a manufacturing environment, this tank existed and the fabricator was tasked to design the replacement part and fabricate it and install it. So the value of getting the connection points correct was very high to this fabricator. So In this case, what we did was we helped the fabricator to quickly get scan of the tank on site, and then from that scan generated CAD geometry to help their design process. And this is a case where a 3D model didn't exist at the beginning, and we actually helped them to design the 3D model. This assembly, of course, is pretty large, so it's going to take between 10 to 30 seconds for it to load. So now I have my assembly loaded. So you can see that this is the 3D scan of the assembly in its current location. Now, we have developed some very specific tools to allow you to extract CAD geometry from the raw point cloud. So, for example, we're able to detect the cylinder, the main tank here, the center line and center points of the bottom and top level. And this was something that Dennis was mentioning about, like the location of P1 or the elevation of P1 is something that's really hard to get with a tape measure. We also help with getting the location of connection point P4 as well as the connection point of P5. And this CAD geometry can be exported into a step file that can be then used as part of your SolidWorks design to get the elevation and coordination of these connection points, so that when you fabricate and install the new assembly, you're not going to run into any issues. So these are the 4 cases that I wanted to talk about today. With that, I'd like to hand it over to Rob. I want to be cognizant of everybody's time and open to questions with that.
Marty, just before you do that, I just wanted to jump in on that last example that you gave, because this is an ALPS example that Marty is talking about, and I'll give a little bit more context. This was for a customer of ours that had a plastic tank on site. It was in service, and they had decided that they wanted to replace it with a metal tank, but they had no drawings for the tank. They didn't have any drawings for the new tank that they wanted. They just told us, look, can you make a metal tank that's it's going to fit where this one is, and the connections are all going to be in the exact same place. We need you to just build a new tank in metal. And so, we would typically go into a site like this and try to take as many dimensions as we could manually and try to build a drawing from those dimensions. And, we would use tape measure and, try our best to get it right. Which is risky, obviously, because it's easy to have a wrong reading. And then we would maybe build some flexibility in place so that we could, for example, if we didn't know exactly where a connection went, we might leave that connection loose and then cut and weld it when we do the installation. In this particular case, I think we had about 36 hours to do the installation to get the old plastic tank out and the metal tank in. So there was no time to, fabricate nozzles on site or adjust connections on site. We had to build it in our shop, and it had to fit. So, it was really helpful to be able to have that scan to identify where all of those connections would go. And then, as Marty mentioned, like some of the connections, I think, I'm trying to remember which angle we're looking at this from, but I think there's a connection on the back side of this, on the wall side, which is very hard to measure relative to the other nozzles. So yeah, that's the P4. So having the scan, we were able to say, okay, we know where that nozzle is going to go relative to the other ones. So I really don't think we could have, I don't think we would have been as successful if we hadn't had this scan. It would have been a much more difficult project, or we would have had to allow a lot more time for the installation. So sorry, Marty, I didn't mean to jump in and
that was great.
At the time, but I wanted to give a little bit more context for how useful this was.
No, absolutely. Thank you, Dennis.
Well, guys, thank you for that. Always having real world applications and how they've solved problems is a real contribution. Thank you very much. Plus, seeing how metrology is used in large-scale assembly applications is really exciting, and why CAD Micro over a year ago started this path of offering glove systems as a solution. and paired with area scanning technology. So at this time, Sarah, I think we're going to move over to a couple questions that have come in. Why don't you take those now?
Awesome. Thanks, Rob. Thanks, Madi, and thanks, Dennis. That was fantastic. Like Rob said, we'll go ahead and get started with the questions we have. But if you do have any questions for us, please make sure to type those into the GoToWebinar panel now. But I'll go ahead and get started. So the first question I have, Madi, is for you. And the question is, how long does it take to get an initial inspection?
That's a very good question. Thank you, Sarah. So it depends. It depends on the assembly size that we're looking at. So if you want to think about time, I would break it up into two major parts. One is the data acquisition, like getting to an actual 3D scan, and that is pretty much linear with the size of the assembly, although not necessarily. So if you're looking at a pressure vessel or tank, we're talking about between 10 to 30 minutes. If it's a very complicated module, we're thinking about 30 to 45 minutes. And if it's a whole plant, then that's a different story. But then once you have the scan, and you can think about getting to that scan in different ways. You can think about it as having your own scanner and your own team and your own trained crew to do that for you. And there's certainly ways to do that. And then you could also think about hiring services and getting services for that part. Both options are viable options, and depending on the volume of your work, the sophistication you have in terms of how much you want to build this into your process, then the answer of which one's more economical is going to be different. Now, once you have the actual scan, getting to an actual analysis is very fast. Once you have your model loaded and your scan imported, getting to the heat map analysis can be less than 5 minutes. And then if you want to do more sophisticated cylinder detection or circle detection or plane detection, more metrology type tools, well, then that takes another 5-10 minutes. But the key thing is you could get to a rapid visualization very, very quickly once you have your data ready. So it depends on the application to answer that accurately, but that's kind of the high level answer I can give for this session right now.
Yeah, and I can validate that, from a real world shop floor point of view. When we have a scan done, it's 20 to 30 minutes, kind of start to finish. And it depends, if you want to get scans from more angles and more multiple scans, it can be up to an hour. But yeah, that's the time it takes to take the scan. And once you've got the data, yeah, super quick and easy to do the comparison and do further analysis on it. The real, I guess, time investment is just to set up and take a good scan, and that's 20 minutes to an hour kind of thing, depending on size.
Yeah, and in terms of value, if we made it easy enough so that the fabricator and the project teams themselves could take the data and then do their own analysis, as opposed to hiring a third party that would come back in a day or a couple of days with a PDF report with how they can make the adjustments that they need. So it's about control the data, managing the process yourself, and then having it easy to use, and then owning the data.
And the other thing I'll add on that, if I'm not going too far off topic, is that once you've done that 20-minute scan, or even if it takes an hour to do the scan, you've got all that data that you have forever, and then you could do whatever you want with. So we have certain critical dimensions that we inspect, and so we'll do a scan and we'll verify those dimensions. But then other questions will come up, like, will it fit this other connection in the field? Or did you guys take a dimension of overall length? And we'll say, well, that wasn't one of the critical dimensions we were supposed to check, but we've got the scan, so we can do that now. And so you have that data that you can go back to, and you can perform additional inspection and verification, even if you already shipped it to site. You've got that data to do whatever you want with after that. You can't go and remeasure it. But you've taken the measurements of everything in the scan, so it is useful to use afterwards as well.
Thank you.
Awesome, thank you both. We do have a question here, and it said, Dennis, in scanning the large plastic tank, what was the largest dimension What was its largest dimension? What resolution and accuracy did you get from the scanner over that dimension? And how many scanner setups did you have to make?
So that's probably a better question for Madi, because he can give you those technical details. But as I recall, that was about 14 feet in height, if I'm remembering the project correctly. Is that right? It's about 14-foot high tank. So, you know, that's kind of the biggest dimension. But Madi can comment more on the resolution of the scan. So
yes, sure.
And how many scans?
Sure. Yeah. In terms of scanner setup, we used 6 scanning locations. In retrospect, we could have even been more optimal, but when you go on site, you want to get as much data as you can. So you invest a little bit more so that back in the office you have that confidence. So 6 scanning locations. And in terms of resolution and scan, we use the scanner behind me, this one. They're higher, more accurate. This is a Faro M70. And so we were able to get it down to 1.5 millimeters in registration. However, if you need more resolution, CAD Micro and Rob Johnson have models that provide that higher level of accuracy. So it really is a conversation about what are your requirements and what best serves you. So we could have that conversation.
And on the question of resolution and tolerances, one feature that I find extremely useful in the glove systems, which I don't think Madi demonstrated, it was on screen though, was that there is a slider that you can use on the screen to change the tolerance for what's green and what's red. So you can say I want everything to be within 1/16 tolerance, 1/16 of an inch. And you can set the slider there and you can see what's green and what's red. Or you can say, well, the tolerance on this project is 1/8 of an inch. And you can move the slider and you can see what's green and what's red relative to that dimension. And I find that very useful because sometimes we'll look at something and we'll see some red and we'll say, well, hang on a second, let's move the slider. And then you can get a pretty quick sense for like how far out that thing is just visually. There you go. Yeah.
This is the slider. Yes, thank you, Dennis, for reminding me. Yes, so the slider allows you to get it up to 6 millimeters and visualize how your deviations are, or you could slide it all the way down to 3 millimeters, 3.4 millimeters in this case, or 1.8, or whatever you want.
Awesome. Thank you both. And just to also, I know Madi mentioned that we have those solutions here at CAD MicroSolutions for more accuracy. For anyone joining us from the States, we also have Point3D. They also offer those similar solutions. So just wanted to highlight that.
Thank you, Sarah.
No problem. The next question I have, Madi, I know we're kind of looking at that tank, but what are the part types you typically inspect?
Yes, so that's a good question too. So our experience so far has been mostly with pipe spools, skids, modules, condensers. Recently, Rob's taking our application to car manufacturing, although that's not a primary application. But realistically, if we go back to the initial product positioning, anywhere you've got highly engineered, medium to large to very big in size is where we work in. We've even experimented our product in concrete fabrication. They have their own set of needs as well. So it's really about size, sophistication, and tolerance. And we've done pretty much everything you could think of when it comes to engineered parts, and we're open to do more. But that's kind of where you get value from using a tool like this.
Yeah, just to comment on the application side, Madi mentioned automotive. It was more, let's call it a large scale vehicle aftermarket. And they're not looking to hold, micron accuracy. They needed a quick way, and quick meaning under half an hour, to scan the interior of the whole structure, but then be able to extract mounting locations and do that very quickly. So when you're looking at about a 15-minute scan time and being able to pull out holes, cylinders, points and just do that off of a very large point cloud, which was 2 gigs when we were said and done. They were able to get all of their mounting locations where 2 months ago they were doing it by tape measures and digital pictures, and now they've got a full digital copy, as Dennis was saying, of the whole part before it goes out the door. So if somebody asks another question tomorrow about how things are going to be mounting together, you've got the full digital suite available to you if you need it. So yeah, we're just finding new markets and new industries that need this quick inspection and quick data gathering process within the relevant manufacturing space.
And Rob, you mentioned something there that if you don't mind, I'll expand on, is just the using this as a documentation tool or a communication tool. I think this is going to be one of the biggest value added pieces for us using this tool, is that once we've done a scan, so we build something, and then like we're building something right now that we're going to ship to Argentina. Okay, we ship stuff really all over North America, and some of these sites are remote, and we ship something, and they're waiting to receive it, and they've got other equipment that they've got to connect our equipment to on site. By doing a scan like this, we can share that with our client, in the cloud. They can see what they're going to get, and like the real thing that they're going to get. We usually do as-built drawings, and if something is the dimension's different but it's within tolerance, it's acceptable, we document all the actual dimensions. But we can now share a real scan, 360-degree scan with our clients, and they can verify everything that they need before the unit gets there. So if they have piping that's going to connect to it, they can see what they're actually going to get, with a high degree of detail. And so that's all documented, and it's provided. And if that arrives and something is wrong with it, it's been damaged in transit or something like that, we now have some evidence that says, look, we scanned this. This is what it looked like when it left here. So there's some, defense that it provides us. But it's a great communication tool so that the customer can see what they're going to get and what we've built. And I think that's going to be a huge value add.
Awesome. Thanks, Dennis. I guess on that note, looking at the glove systems, software, one question I have is, can someone start with services and then move into making a purchase of the software? How does it typically go, Madi?
I guess Rob could answer that too, but the answer is yes. I mean, we don't do services. We rely on our partners to do that, and really the goal of those services is to show the value, allow you to experiment if you haven't done anything like this before, at a pretty low cost. Of course, it can't be zero, but at a pretty low cost for you to experiment, get the value, and then make a decision. Those things can be arranged, but it will go through our partners, either Point3D or CAD Micro.
Awesome, thank you. And the final question that I think we've kind of touched on, but it would be good to expand just a little bit, is what is the accuracy that you can inspect to?
Yes, so we touched on that a little bit. And the accuracy, in the world of laser scanning in general, sub-millimeter is kind of hard to achieve. It's not realistic to ask for it. So, but then once you get a millimeter and above, you have a variety of options. As I said before, CAD Micro reps a type of scanner that provides that level of accuracy, a very, very high level of accuracy. There are other options too, but the world of large scale metrology or large scale laser scanning, you're typically looking at somewhere between 1 to 6 millimeters, 5 millimeters accuracy, with one being very, very ambitious, with 5 millimeter kind of being at the other end of it. So that's kind of the range you're looking at.
Awesome. Well, that's all the questions I have. If any questions do arise after we finish here, please feel free to respond to the email we'll be sending out with the recording. We'd be happy to get back to you and answer any questions that might come up afterwards. So again, I want to say a big thank you to Madi, Dennis, and Rob. I think this was a fantastic presentation, and I'm really happy for everyone who joined us here today. So thank you again, and have a great rest of your afternoon.
Thank you.
Thank you, everyone.
All right, thank you.